Hello students, this is the next topic under module 2, comparison of load flow methods. The comparison is carried out based on time taken per iteration, total number of iteration, acceleration of convergence, etc. Okay, let us take first one, time per iteration. Usually time per iteration depends on a number of arithmetic and logical operation need to be performed. In GS method we know that it may be PQ bus or it may be PV bus. Only two parameters in each case need to be calculated. So the computations are very less, calculations are very less. So GS requires fewest number of operation to complete one iteration. In NR method, in this method the Jacobian matrix need to be calculated and P, Q, okay, and delta P, delta Q, and Jacobian matrix need to be calculated at every iteration. After calculating Jacobian matrix, and inverse of the Jacobian has to be taken. Okay, so time per iteration is larger than GS method. It is 7 times the GS method. Okay, if you look at the graph of time unit versus number of buses, NR method linearly varies and GS method almost constant, then it varies, it increases. Okay, in fast decoupled load flow method J is constant, okay, and need to be computed only once, but it is here time per iteration is less than NR method. Okay, next, total number of iterations. Number of iteration depends on the convergence characteristic. Okay, GS method exhibits linear convergence. Okay, and NR method and fast decoupled load flow methods exhibit quadratic convergence and geometric convergence respectively. Okay, therefore it requires more number of iteration, and the NR and FDLF methods the number of iterations are relatively constant, hence total time to complete all the iterations is more in case of GS method. Okay, it is more because number of iterations are more, so total time to complete all the iterations are more. Okay, if you observe the characteristic, okay, characteristic of GS method is just like this. As number of buses increases, okay, as total time of the operation increases. Okay, total time of the operation increases. NR method total time is almost constant because total time to complete all the iterations it's very less because only few iterations are required. Okay, almost 5 iterations, not more than 5 iterations are required to get the accurate value. Okay, so NR method total time of iterations are very less. Okay, it is quadratic convergent. Okay, and FDLF method it is geometric convergent. Okay, influence of acceleration factor. The rate of convergence is very less in case of GS method, and NR method require about 5 to 8 iterations for convergence in large case of the power system. Okay, the rate of convergence can be increased in GS method by the use of acceleration factor. We know that if it is not convergent, what we are going to do? We are going to multiply it by the acceleration factor, thereby we reduce the number of iterations, okay, by making it convergent, right? So how it affects the GS method, we'll see. The acceleration factor value which is taken between 1.4 to 1.6. Okay, the graph which is just like this. Okay, just like this. As acceleration factor is multiplied, okay, total time of iteration gets reduced because number of iterations gets reduced because of the convergence. Okay, adaptability for the power system calculations. GS method requires fewest number of arithmetic operations. In NR method, calculations of Jacobian is necessary in every iteration. Inverse of Jacobian has to be computed. Okay, here computations are more. In GS method, computations are less. In fast decoupled load flow method, the Jacobian is constant and needs to be calculated only once. Okay, even Jacobian, it has a reduced number of calculations. Okay, if you take coordinates, okay, Gauss-Seidel works well with the rectangular coordinates. Newton-Raphson method works well with the polar coordinates. Okay, and fast decoupled load flow method works well with the polar coordinates. Arithmetic operations are more in case of NR method and least in case of GS method, and less than NR method in case of fast decoupled load flow method. Time per iteration, since arithmetic operation is less in case of GS method, time per iteration is very less. Okay, Newton-Raphson method, time per iteration it is 7 to 8 times the GS method. Okay, fast decoupled method, the time per iteration is less compared to the NR method. Convergence, we know that Gauss-Seidel method it is linearly convergent, Newton-Raphson method it is quadratic convergent, fast decoupled load flow method which is geometric convergent. Number of iterations are more in case of GS method. Okay, that is the main drawback of the GS method, just with the increase in number of buses. Okay, so number of iterations are very less in case of NR method, it is 3 to 5 only. Fast decoupled method, only 2 to 5 iterations are required. Slack bus selection, okay, slack bus selection affects the GS method. The case of NR method, okay, sensitivity to this slack bus selection is minimal. Okay, and fast decoupled load flow method, it is moderate. If you take the accuracy, the Gauss-Seidel method is less accurate, okay, and Newton-Raphson method which is more accurate, and fast decoupled method which is moderately accurate. Usage or application, Gauss-Seidel method is used in small size system, Newton-Raphson method is used in large systems or ill conditional problems or optimal load flow studies. Okay, and fast decoupled load flow method is used in optimization studies and multiple load flow studies, contingency evaluation. Next, programming logic which is very easy in case of GS method because it has fewer number of operations. Okay, in Newton-Raphson method the programming logic it is very difficult because each and every step Jacobian need to be calculated and inverse need to be calculated, right? The computations are more, so programming logic it's quite difficult compared to the GS method. The programming logic is comparatively easier than the NR method in case of fast decoupled load flow method. Reliability, GS method which is reliable only for smaller system, okay, and NR method reliable even for large system because it gives the accurate data, correct, accurate answer. Fast decoupled method more reliable than the NR method.